Alright, so we're going to spend some time today talking about systems of equations. And this is kind of a prequel to distance equals rate times time problems, because all the setups are based on D equals RT problems. But today we're going to just work on solving the systems, and at the end of each problem I'll try to explain what type of distance equals rate times time problem it would be. So I start by counting equations. 1, 2, 3, 4. So I have 4 equations. The question is, how many variables do I have? 1, 2, 3, 4. And they're all the same, so I have 4 equations, 4 variables. This is solvable. Now, we might not like it, but we have to recognize this is R of A, T of A, R of P, T of P. These are separate variables. I see I have RP, TP, and TA. So I will fill those into the first equation. And I will use parentheses to substitute values in for these. And you can see that this quickly simplifies to a pretty easy two-step problem. So I move the 200 over, get 3RA equals 120, divide each side by 3, and I get R sub A, or RA, is equivalent to 40. And I just solved this system of equations. Now, if we're talking what kind of problem this could be a distance problem. Adam drove for a while, Peter took over and drove a little further. The total distance for the two was 320 miles. If Peter drove 50 miles an hour for 4 hours and Adam drove 3 hours, what rate must Adam have driven? And again, it comes down to making a great picture. Distance of Adam, distance of Peter, 320 miles. And the first thing that happens is dA plus dP equals 320. But anytime we have dA, we're going to get RATA. Every time we have distance of Peter, we got rate of Peter, time of Peter. It's something we'll talk about as we go forward. I just want to realize that that's what this is doing. Next, we just have 3 more examples. Again, we'll count variables. I see 4 and 4 equations. It is simply a substitution matter again. I know R of T, I know R of R, and I know that TT is equivalent to TR. So I'll fill this in. 2. Replace TT with TR, plus 120 equals 10. And I won't replace TR here with TT because I want one variable. And if I replace it, I'd still have 2. Now I have one equation, one unknown right here. I'll move 2TR to the other side. By subtraction, 120 equals 8TR. Divide by 8. And I get TR equals 15. And if TR is 15, what's TT got to be? It is also 15. Again, pretty straightforward problem. 4 equations, 4 unknowns. Oh, I said I'd say what kind of distance, rate, time problems. Tommy went 120 miles less than Ralph, and then gave some times and stuff like that. And again, we'll have to develop these equations later. Here's a case where RLTL equals RSTS. The distance of Lenny equals the distance of Scott. Alright, and again, we have 4 equations, 4 unknowns. It's solvable. I know RL and RS. And I know TS is equivalent to TL minus 5. So I'll start plugging in. So I get 40 TL equals 80 TS. And this time I waited here because I wanted to show you the numbers going. And now I have these 2 equations. Well, it's substitution. So 40 TL equals 80 parentheses TL minus 5. Because TS and TL minus 5 are equivalent. This is all on equivalency. We can distribute. And this becomes, again, just a simple 2-step problem. And if you can get here, most of the time students feel pretty good. It's just a struggle to get here. And I get TL equals 10. It's just simply a plug and chug. And if you hit a wall, you got to go back and try something else. Last problem for today. Another one like this, where the 2 distances are the same and we substitute, we end up with this. Again, I know TF, TE. So I'll do it those 2, and those are the number ones over here, alright? So I'll take care of those. So I get 12RE equals 16RF. And sometimes I cross them off when I do this. So then I can say, hey, I use these three. Well, what two does that leave? It leaves the one I developed and this one. Well, I can replace RE. So 12, instead of RE, I can write RF plus 15. Alright, I'll distribute 12RF plus 180 equals 16RF. And I'll subtract 12RF on both sides. And I'll get 180 equals 4RF. Divide by 4, and I get RF is equivalent to 45. Again, kind of a different way to look at it. Instead of developing equations, we'll become accustomed to using them. Have to recognize that subscripted variables are simply one thing. There are only 4 things in the original equation. But with some practice, this becomes easier.